Good morning, students. In today's class, we are going to discuss about advanced data structure in R. So, in previous classes, already we seen different types of data types, primitive data types, and other data types available in R. Coming to the advanced data structures, already we have seen one data structure in advanced data structures, that is vector. That is a single dimensional line or one dimensional data structure. And what are the other types of data structures that are available in R other than vectors? For two-dimensional, multi-data types, and single-dimensional multi-data type, different types. So vector itself is nothing but a single-dimensional data structure which can allow same values, that is similar data type values for all elements. When we are coming to the one-dimensional multi-type data structure, that is a list, and two-dimensional single type, that is an array, two-dimensional multi-type, that is a data frame. So different types of other data structures available, because R itself is providing a visualization of charts and other representations. So when we want to explore the data using a chart, that should be a two-dimensional structure. So there should be a data structure that should support two-dimensional data. Then only we can explore that in chart or map formats. So for that purpose, R should support advanced data structures compatible to visualization. So what are the different types of advanced data structures other than vectors available in R? We can see one by one. So coming to the list of advanced data structures in R, first one vectors, next arrays, matrices, that is a two-dimensional, array is single dimensional, and list, single dimensional, data frames, that are also two-dimensional, and classes. So these are the other data structures which supports one-dimensional and two-dimensional data representation, single data type and multi-data. So array itself is a single dimensional, one-dimensional single data type. Matrices, two-dimensional single data type. List, one-dimensional multi-data type. Data frames, two-dimensional multi-data type, and classes, that are object-oriented representations. So here in today's class we can see how we can access arrays, that is single dimensional, similar data type data structure. So in this class we show how to create an array in R, how to access the array elements, performing arithmetic operations on arrays in R programming with different types of examples. So first coming to how can we represent an array, what is the syntax of an array declaration, and how can we create the arrays and other operations we can perform on arrays. So coming to the array syntax. The syntax of array in R programming language is, so here you can see the structure, name of the array, that is array name, assign array of data which we want to pass if that is static, comma, dimension equal to row size, comma, column size, comma, matrices, comma, dimension names, that is nothing but if that is matrices, then you can specify the row names and column names. If you observe the above code, data is a vector. So here array itself is already we told itself is a vector which is also a similar accessing similar data elements. So here array itself may be a matrix or may be a vector, but here we have to specify the parameters arguments or parameters we are specified in the syntax. Coming to the matrices, it will be decide the number of matrices an array can accept. An array in R is always a multi-dimensional. It means more than one matrix with rows and columns. So here we can array can hold multiple set of data elements in form of matrix structure. And next coming to the row size. Here we have to specify the boundaries for the array, that is number of rows and number of columns. So row size, please specify the number of row elements an array can store. For example, row size equal to 5, then each matrix in the array will have 5 rows. Next, column size, the number of column elements an array can store. For example, column size equal to 6, Then each matrix in array can hold 6 columns. Next, dimension names. It is used to change the default row and column matrices names to more meaningful names. That is, if you want to specify the headings for the row and columns, then you can use this argument. So, row size is row boundary, column size, column boundary, dimension names, name of the rows and columns, and matrices, number of matrices we are specifying for an array. That is nothing but the maximum size of it. Next, how can we create an array? In this example, we will create an array. So here simply you can see the following code snippet. The following code snippet will show you the most traditional way to create an array in our program. So simply here we are creating an array A. So here for creating an array we have to use always the reserved word array. So A array of 1:24, that is nothing but ranging the elements from 1 to 24, dimension equal to 3, 4, 2. That is nothing but dimension names. So here print A, display array, and next vector 1 is created C of 10, 20, 30, 40. Vector 2 is created C of 50, 60, 70, 80, 90, 100. Next, we are creating another array B, array of C of vector 1, vector 2, dimension equal to C of 3, 3, 2, print B. So, what is the output we can get after executing this code in R? We can see next one. So, here vector 1 creating two vectors, and next we are displaying passing those two matrices to array through array to B, and first one is only displaying array A without any, that is the array A is single dimensional, but here in array B is two dimensional consisting of two vectors. So what is the output we can get? So here you can see here. So when you print A, so see here when we create this array and next print A, then automatically it can create the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is nothing but here this is a two-dimensional 3 rows and 4 columns. So two-dimensional structure with 3 rows and 4 columns. So row measure, so we have column measure, we have C of means column measure. So we have to pass the values first for column measure. So 1, 2, 3, first column, 4 to 5, 4, 5, 6, 7, 8, 9, and 10, 11, 12. That is up to 1. But here we are creating 2. Then 2 vectors. Then distributing the values into 2. So 3 into 4 means 12. And again creating another matrix with other 12 elements, that is 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And again here we are creating 2 vectors and passing those two. This is nothing but by directly as random we are passing the values by specifying the range 1 to 24. This is the first example. But in second example we can initialize the values to array instead of random values. That is nothing but through vectors. So first vector consists of 10, 20, 30, 40. Second vector 50, 60, 70, 80, 90, 10. So we are for a vector 1, vector 2 dimension 3, 3, 3 dimensional 2. So here this is displaying 3 dimensional 3, 3, 3 by 3 and 2 matrices. So 10, 20, first vector 1, vector 2, 10, 20, 30, 40, 50, 60, 70, 80, 90 up to this. And next again we are restarting from the remaining elements, that is from 100. And 100 and rearranging again from the beginning for the second matrix, because here we are passing 2. So we have to display the elements in 2 matrices. So this is how can we create an array with a randomly range of elements or by passing the static elements to in form of vectors to arrays. So this is how can we create. And next one, this is nothing but analysis for the above example. The below statement will create an array of elements from 1 to 24 arranged in 2 matrices, and each matrix contains 3 rows and 4 columns. That is A of array 1 to 24, dimension C of 3, 4, 2. Next we can create two vectors. And from the above screenshot you can observe that we are using C or concatenation function to combine those vectors to create an array of elements are arranged in two matrices. Each matrix contains 3 rows and 3 columns. That is concatenation. If the elements are not available, you can concatenate the remaining elements with the previous vectors for getting the complete dimensions of the matrices. Next one, how can we define row names and column names for that? So in this example, we can show how we can create row names and column names to an array. So we will show how to replace the default names of row and columns and matrix or matrix. Define new names for the rows and columns in the matrix. So here you can see X is a matrix of 1 to 12. Dimension names equal to list of row names column, column names, matrix. So here we are creating the previous one only. 1 to 24, dimensions is 3, 4, 2, print here. And again here, this is default 1, 2, that is the indexes for the row names and column names. But here I want to change those indexes with row names and column names. So row dot names of C of row 1, row 2, row 3. And column names, column 1, column 2, column 3, column 4. Because 3 rows and 4 columns. Row names are row 1, row 2, row 3. Column names are column 1, column 2, column 3, column 4. And matrix names, matrix dot names, matrix 1, matrix 2. So B array, here you can display B array with the newly assigned row names, column names and matrix names. 1 to 24, dimensions is 3, 4, 2. But dimension names are list of row dot names, column dot names, matrix dot names, and again print. So what is the output we can get? Here we can see. So this is the initial list. That is without assigning row names and column names, the matrices. That is 1, 2, 3, 4, 1, 2, 3. When we are assigning the row names and column names, matrix 1 is row 1, row 2, row 3, column 1, column 2, column 3, column 4, matrix 1. Matrix 2, row 1, row 2, row 3, column 1, column 2, column 3, column 4. So this is how can we assign new names for rows and columns. This is most important when we are dealing with Excel and other data frames. We have to assign our own names for the tables, rows and columns in the table. And next, how can we access array elements? In our programming, we can use the index position. Always we know in other programming languages, always we can use the index for accessing the array elements. So, access the array elements using the index, we can access or alter each and every individual element in the array. Index value starts at 1 in R, but in other it that starts at 0 and ends at n when n is the size of the matrix, row or column. The syntax behind our array accessing is array name of row position, column position, matrix. For example, we declared an array of two matrices of size 6 rows and 4 columns. To access or alter first value, use array names 1, 1, 1. To access or alter second row, third column value at first matrix level, then use array names 2, 3, 1. And to access the sixth row, fourth column in second matrix level, then use array names 6, 4, 2, etc. That is, use the indexes and display the array elements. So here you can see the example. Accessing array elements. A, array of 1 to 24, dimension C of 3, 4, 2. That is normally previous one. And access the element of first row and second column in matrix 1. Then row position first row, column position second, and matrix is 1. And access the element of third row and fourth column in matrix 2. Then 3, third row, fourth column in matrix 2. And access only the third row in the first matrix. So leave the column position. So 3, first row, first matrix, third row, and Access only the third row in the first matrix. Access only the fourth column in the second matrix. Leave the row position as empty. Access the complete first matrix. Leave both row and column as empty and 1. Access the complete second matrix. Here you have to pass to by mistake. So this is how can we access the elements by using the index positions of row and column and matrix. So this is the output. So first row, second column, that is 4, first matrix. So third row and fourth column, the second matrix, that is 22, etc. Access, when we want to access all the elements of the array, simply you can pass this. That is, we can pass this, that is completely, you can specify the element of array and simply you can pass the row position, column position and matrix position. So this is it, how can we access all the elements in the array, you can pass. But you can put this in a for loop, when we go through control structure, then we can say how. So this is the output for accessing the elements by passing the index. And next one, accessing the subset of array elements. Subset of means only getting a specific set of elements from there. In our previous example, we show how to access the single element from the array. In this example, we will show how to access the subset of multiple elements from the array. So, for accessing subset of multiple elements, we have to use R. So, navigate the index position is used to omit. So, here when we want to remove some subset of elements, we can use the negative value of the index position. So, accessing array elements. So, this is the array. So, print A, C of 1, 2, C of 3, 4, 1. Then that can display only the specific elements from the matrix 1. When access all the elements of second and third row, then leave the second one. Then access all the elements of first and fourth column, then leave the first one and put only the second. When access all the elements except second and third row, so already we told, that is we have to use the negative indexes for removing those values. So here we have to omit the second and third. So -2, -3 come and remaining element should be displayed from matrix. So this is the output. So when we are accessing first row, second column and third row, fourth column in matrix 1 and similarly in matrix 2. Removing second row, third column, removing the second one and similarly here. This is the row measure, this is the column measure. When we want to remove consider row measure, are the row elements, not the column elements, then we can specify row measure. When we want to display column wise, then we can specify column measure. When we want to remove some elements from the matrix, we can specify those indexes in negative. So this is accessing some subset of elements from there. And the last one, how can we perform arithmetic operations on arrays, that is array addition and subtraction. In this example, we can show how to use arithmetic operators on matrices to perform arithmetic operations. So adding and subtracting elements of the matrix. Vector 1 is 10, 20, 40. Vector 2 is 55, 67, 89, 96, 100. So a array of vector 1, vector 2, dimension 3, 4, 2. Print array A. And here we are performing a mathematical matrix A, mat dot A of matrix 1, mat dot B, A of matrix 2. Then here we are printing matrix A plus mat dot B, that is addition of two matrices and subtraction of two matrices. So, but when we want to perform arithmetic operations, we have to convert the matrix dimensions into same type. So for that one, here you have to first convert that into one dimension. So here this is the output. So converting into one dimension and next adding and subtracting. So here this is the first matrix and this is second matrix. And we are performing addition. You can see here this is the result of addition, this is the result of subtraction. So this is up to arrays. But here, what are the example codes here I have been put in slides in PPT. You can practice this in R because you are having the practical in R. So you have to practice all these operations by installing R in your system, and you can practice those at your command prompt. So you can practice those at the command prompt, or if the R Studio is available in your system, you can practice in R Studio also. Both are same. There is no difference because both are not visualizing any outputs directly. Both are command oriented. So you can practice this. This is up to arrays in R. In next class, you can see matrices and lists.